Hey, hello. Hey, you guys seem to be doing pretty well with the Lewis dot structures. I'm trying to give you a little bit of feedback. For the most part, I think you caught on to that really nicely. I'm anxious to start seeing your 3D shapes that you draw. There's one more thing about Lewis dot structures we want to go over, and that's what are called resonance structures. So we're going to do two examples for you. Of course, you recognize that ion, nitrate, right? And this is O3, which is ozone. So these follow the octet. We're going to use the tally method, and we'll see that why these are special. Okay, so let's start with ozone. Ozone's made up of 3 oxygen atoms, compared to oxygen, which is made up of 2 oxygen atoms. They're called allotropes. Other allotropes are graphite and diamond are allotropes. They're made up of carbon, just different. The carbon atoms are bonded differently to each other. So oxygen and ozone, allotropes of each other. So let's draw a Lewis dot structure for oxygen. So we're going to take, we know there's 3 oxygens. Each oxygen has 6 valence electrons. So we have 18 valence electrons to work with. 18. Let's draw a skeleton, okay? So how many electrons did we just use? 1, 2, 3, 4. Yep, 4. Minus 4. So that leaves us with 14 electrons. Or, divide by 2, that's 7 pairs. So I have 7 pairs to make the octet rule work. Okay, so let's just distribute those 7 pairs around. See what happens. 1, 2, 3. That's looking good. 4, 5, 6, 7. So these oxygens on the outside certainly follow the octet, but the problem with this oxygen only has 6 around it, 6 electrons. Remember, that's electron 1, 2, 3, 4, 5, 6. So remember what we do. This doesn't have a charge. We just can't add valence electrons. We only have 18 to work with. We just use them all. What we can do is slide these 2 in between. So these 2 electrons count for both atoms. So let's do this little slide thing. All right, now we have a double bond. All right, okay, so that's ozone. Now, it turns out that if you do some experimentation with this molecule, the strength of this bond, it's not a double bond. It's more like a 1.5 bonds. And this single bond is stronger than a single bond. It's actually more like 1.5 bonds. So there's no one Lewis dot structure that can represent this. So what we do is we draw the extremes. So we would put this in brackets. We would use an arrow and then draw the double bond here. Now notice how I'm drawing this. We know that this lone pair is going to push down. Let me use a different color, excuse me. This lone pair is going to push down on these bonds. So it's angular or bent. It's certainly not linear. So that's important to realize. Resonance structures. We used to think that the bonds resonated like a swing resonates back and forth. So these valence electrons would move and move and move. But that's not the case. That's where we come up with the phrase resonance. It just turns out that this is really 1.5 and that's really 1.5. So someone thought, why not just draw both extremes? And that's how we show that it's a resonance structure. Okay? All right, let's try nitrate. Let me just, excuse me again, let me just find some room here to do nitrate. All right. Nitrate. Let's use the tally method. Nitrogen has 5 valence electrons. Oxygen, there's 3 oxygens, each have 6. And remember, -1 means we gain an electron. We just add an electron. And that can go wherever. We'll figure that out. So we have 18 plus 6, 24. All right, so we have 24 electrons to work with. Let's draw the skeleton. All right. How many electrons did we just use up? 6, yep. All right, down to 18. Divide by 2, 9 pairs. We got 9 pairs. Let's just distribute them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Who do we appreciate? Okay, that's it. All right? Is that cool? Does that follow the octet? Nitrogen has to follow the octet. Oxygen has to follow the octet. Yeah, nitrogen is short 2 electrons. So we can do the slide. We'll slide these 2 in between. All right? And now around this oxygen, we still have 8. Around nitrogen, we have this 8. We have 8 as well. So that's the Lewis dot structure for nitrate. So again, this is in a double bond. These aren't single bonds. If you look at that bond energy chart, it tells you the bond strength for between nitrogen and oxygen. It would turn out to be greater than that. You'd have to add more energy than what that bond chart says. So how many resonance structures do you think we would have to draw? How many different resonance structures? Yeah, 3. So what we do, we just want to draw all 3 of those. And we use, let's put a -1 there, okay? Let's put, let's draw, okay, notice I'm drawing this trigonal planar. These will try to spread apart as much as possible. A double bond pushes basically the same as a single bond. So we're going to show that this is trigonal planar. And then of course we draw one more. Yeah, sorry about that. So I can draw, we can draw one, let's put the double bond here. Now it's important with that double bond, there's only 4 more valence electrons if you have that double bond. So just be careful with that. So 3 valence, 3 resonance structures. And I'll give you a few more to do for practice, okay? So again, what we do is we use the tally method. If we find that the double bond can be in multiple places, we want to draw the extremes. We got to use brackets with a double arrow. That's not a double arrow. We put -1 here because these are ions, nitrate ions, and that's all for resonance structures, okay? You should catch on to that pretty quickly, I hope.